I'm glad that you are interested in our initiative, St Albans Greener Together, which is an initiative that is partnered by the St Albans City and District Council and the University of Hertfordshire. The initiative has been funded by the Innovate UK, and the initiative is designed to empower local people and groups to make a difference to innovative behavior change campaign. We would like to enhance the understanding of the invisible impact of everyday choices and the combined benefit of everyone making a small change to reduce energy and transport emission. This is the second event of the course, and I can say the first one with Laura Byrne went really well, really informative, great chat at the end. And I'm sure that this time will be the same with Mirko Farnetani as well. I will leave now to Dipti to introduce today's session and introduce Mirko as well.
Hi
Thank you.
everyone, welcome to the session. And today I'm happy to present Miko, who is an expert in embodied carbon and circular economy and is trying to push whole life carbon in his profession and in his work on a daily basis. And I'd also like to share my screen and speak a little bit about what we have. So the last session was from Laura Barron, and as Luigi said, it went really well. We have a few more sessions coming up about natural materials, net zero, operational in new buildings, circular economy, and regenerative designs. And I encourage all of you to join them as well. And thank you for joining today's session. And we have a huge line of great speakers coming up as well. So I'd like to encourage all of you to pick up your phones and scan this Slido poll, to scan this QR code to start with a poll just to know about yourselves and where you come from and what your background is. So firstly, you can go to the next slide. Yeah. So firstly, I'd like you to type about what your profession is and what you do. I say student, architect, academics. Product designer, interior architect, sustainability consultant, architectural student, project manager, investor. Okay, interesting group of people. It's amazing to hear. Okay. So going to administrators, got it. Amazing. Warehouse associate. Amazing. I'm gonna go to the next question. And did it move? Oh yeah, okay. So what's your level of knowledge on whole life carbon in buildings? Okay. About 50% of the people have a basic understanding, and the next one's a lot of people who don't have an understanding. So I guess it's a good mix of people for Miko to address. Yep. And then going on to the next one. Have you ever prepared for the people who answered that they have a basic understanding? Have you ever prepared an embodied carbon metric? If yes, then how? Okay. Yeah. That's a big win for Never. So I guess Miko has a big job to do in the next 1 hour.
Yeah, perhaps the session will be useful for most of you, probably.
Amazing. Okay. So I'm gonna stop sharing my screen. Thank you all for your input. And I'd like to hand it over to Miko.
Thanks very much, Deepti, for the invite. And of course, thanks to Luigi and Nick for the invite, for organizing everything. So I think perhaps I can share my screen first of all, and then we can start. Okay, so right. Okay, so I think you are able to see the screen. So probably I will show everything. Yeah, I think now you can see the full screen, I suppose.
Yes, yes.
Okay. Right. So a bit of introduction about myself. Just to let you know my background. So I am an architect by training, but I decided to get specialized in sustainability, and therefore in 2011 I enrolled for a master in sustainability at UCL, and let's say from 2012 I started working as a sustainability consultant. At the beginning, I dealt with dynamic thermal modeling, and from 2014, I start dealing with embodied carbon, life cycle assessment, and circular economy. It was pretty determinant, my experience at Sturgis Carbon Profiling. This company here, at the time in 2014, Sturgis Carbon Profiling was a pioneer company dealing with this kind of service. I have to say that at the time, clients were reporting embodied carbon as an innovation. It is not anymore the case, obviously, because at the moment, this kind of sustainability aspect is more developed, and I wouldn't say is mainstream, but it is now requested by a lot of local authorities and clients as well. So my last work experience was at SOM, where I was an associate and in the sustainability department, and I was also the firm-wide embodied carbon leader. I say that it was my last involvement because I left the company, and now I'm gonna join another one, but I cannot disclose yet which company is gonna be. Anyway, so I think we can start. So the session will be subdivided by two parts. So the first part will be an introduction to all life carbon and life cycle assessment. The second part will be about case studies. And of course, in this case, obviously, there is going to be more detail, obviously. So I think perhaps what we can do is that you can ask questions whenever you want, because there will be a lot of details. So feel free to interrupt and ask questions. Otherwise, we can address all the questions at the end, obviously. Okay, so let's so we can start from the all life carbon overview. So I think so what is important to determine, obviously, all life carbon is to use a tool that it is possible to prepare results for this particular sustainability aspects. And the tool we normally use is a life cycle assessment. Okay. Now, a life cycle assessment, it is a powerful tool for analyzing environmental impact indicators. I would like to stress about environmental impact indicators because what we normally assess in terms of whole life carbon, it is normally one indicator that is possible to assess in life cycle assessment. And the indicator is the global warming potential. The global warming potential is normally called embodied carbon as well. So in other words, if you hear about global warming potential or embodied carbon, consider the fact that they are the same things, obviously. I think what's important in all life carbon, in life cycle assessment and all the indicators is that, by performing a life cycle assessment, it is possible to define a lot of, impact indicators that obviously shows not only the impact in the atmosphere, meaning global warming potential, but also it is possible to understand water pollution, soil pollution, and natural resource depletions as well. Now, so the top three are, let's say, the most used in the industry. And particularly the top one, global warming potential, is perhaps the widely used globally, obviously, particularly by the construction industry. Okay. Now, to be honest, I just wanted to introduce this because it could be that in the future other environmental indicators will be demanded for environmental assessment of buildings. Actually, if your projects will be under LEEDs, the green rating system based in the US and internationally, in order to achieve more than 3 credits, you have to demonstrate a reduction in either 3 or 5 environmental indicators, including the global warming potential. So yes, of course, it is important to know that other are existing and possible to be analyzed as well. Now, so all of these environmental indicators are defined under a few standards, let's say so, but the most used in the industry, particularly in the construction industry, are those 2 standards here. So one is the 15804, which is for products and particularly for EPDs. And the other one is the EN 15978. And this is particular for buildings. Now, if an assessment using the standard 15978 for a building will use data coming from the other standard, the 15804, of course, the level of quality data in terms of result will be the best you can achieve at the moment. So both standards are demanded to be used in all of these documents here to the bottom, and particularly by the London Plan or the All Life Carbon Assessment Guidance. I'm pretty sure if you work in referable project to the Mayor of London, for sure you have to address the All Life Carbon Assessment Guidance. And then, of course, the circular economy statement as well. Okay, so we can go to the next question, to the next slide.
Mirko, before we move to the next slide, we have a question on the
sure.
On the chat. It was by Satanods. Is there any guidance for the indicator other than carbon, CFC, and fossil fuels?
So guidance meaning, I mean, what kind of, what about all the indicators? I suppose so, yeah. So, I mean, in this case, what I would suggest is perhaps the best you could do is to buy the standard, the 15804. So there will be defined, let's say, all the indicators. Otherwise, to be honest, I don't know any specific guidance. Perhaps I can search on the internet, and just in case, I can share with the person who has asked. Okay.
Thank you.
All right, no problem. Okay, so next slide. Okay, so we discuss all the environmental indicators, and what we said is that the global warming potential, it is the so-called embodied carbon. What it is important to know is that the unit for defining, well, for measuring the global warming potential, it is the carbon dioxide equivalent. Okay. Now, the carbon dioxide equivalent, it is a standardized unit that take into consideration all the global warming potential gases. Okay. Unfortunately, it is not only CO2 to generate global warming, but there are a lot of other gases which are released in the atmosphere by industrial activities. And the carbon dioxide equivalent is to standardize the global warming potential of all the gases. Now, so the standardized unit takes into consideration as unit 1 the carbon dioxide global warming potential. And then, of course, the remaining gases here, takes into consideration, obviously, the global warming potential, taking into consideration, obviously, carbon dioxide. Now, if you see methane, for example, you can see that the global warming potential is 25 times the carbon dioxide. And then, of course, if you go down to the bottom, the sulfur hexafluoride, it is 22,800 times the global warming potential of carbon dioxide. And you understand now what are the issue, obviously, about industrial activities, particularly because all of these gases are released in the atmosphere by any kind of activities, right? For example, if you take into consideration the CFC, so these are the typical refrigerant gases which were used in fridges or air conditioning. A lot of these gases are now phasing out. In Europe, there are, a lot of them, they are already phased out. But, in the rest of the world, a few of them are still on, unfortunately. Okay, so next slide. So in order to define the all-life carbon, it is important to understand that the all-life carbon, it is the sum between embodied carbon and operational carbon, okay? And particularly the embodied and operation emissions are to be considered from, let's say, the extraction of raw material till the end of life of a building, okay? So this basically defines the all-life carbon. It is important for you to understand all of these definitions, because if you have to deal with projects, particularly for clients' requests, it is important, obviously, to address all the expression and the meaning of all the expressions, obviously, because in this case, obviously, you have to deliver what the client brief demands. Okay. Now, so I mentioned before that in order to assess buildings, we normally use in the industry the EN 15978. Now, the EN 15978, it is a European standard, and but it is used globally. Okay. It is actually used in the US as well. However, there is another international standard, which is called the ISO. I think it's 22,000 and something, or 27,000 and something, that it is very similar to the EN 15978, but of course, you know, there is something different. However, they are considered as equivalent. Okay. Now, the reason why I'm saying so is because, again, it would be very useful for your personal knowledge to know all of these data, if, of course, you will need to deal with all of these requests, obviously. So this, this graphic comes from the LETI embodied carbon primer. If you haven't downloaded, you can download, because it is for free, available from the LETI website. Okay. Now, so some definitions. So let's say the EN 15978 defines the emissions throughout the building life, and particularly even before the building, the life of a building, meaning from the raw material supply and destruction from nature. Of course, there is a construction activity as well. And then there is the use of the building, which is the B stage. The end of life of the building as well is considered as emission to be reported under this standard. And then, of course, the operational carbon as well. Now, so if we consider, for example, all the A, B, and C module fenced in pink, this is what it is defined as embodied carbon. The operational carbon, it is defined by the standard as operational energy and operational water as well. Now, when we consider operational water, normally it is the water consumption within the building, meaning for example, flushing toilets, for cleaning, and for drinking, and etc. And what it takes into consideration is the water supply and the water treatments as well, once water is wasted in the drainage. The whole-life carbon, as defined before, it is obviously the embodied plus the operational carbon. I think the concept is straightforward, I suppose. So the standard defines another module, which is called the module D. And the module D defines, circular economy benefits and loads. This is defined by the standard, particularly for the reuse, the recovery, and the recycling of building materials after the end of life of a building. Okay. Now, if you consider, for example, the module B4 and B5, refurbishment and replacement, of course, these are emission that happens during the life of a building. In this case, for example, if you take into consideration replacement, if you consider a commercial building, a typical replacement could be the replacement of carpets, floor finish carpets, obviously. And of course, in this case, obviously, the emission should be reported under these modules. And of course, if any piece of carpet is going to be recycled, reused, or recovery, will be reported under the module D as well, because it is considered end of life of a building product, obviously. Okay, so we can move to the next slide. Is there any questions here at all? No? Okay.
Oh, we don't have any question. If there are any, I will tell you.
Yeah, okay. Thanks. Okay, so I think this is a particularly important subject, meaning the scope for carbon reduction, particularly because normally in embodied carbon analysis, what it is important is not only to analyze, but to reduce the impact as well. So normally in a typical building, you know, a kind of reduction between 15 to 25% against a baseline, it is possible to be achieved without any cost increase. Okay, if obviously the building targets, you know, reduction above 25%, it could be that there could be some cost implications. Okay. Now, this is a kind of rule of thumb. So every building is different, and therefore it could be that this percentage could vary. But you can use it as a kind of rule of thumb, obviously. So I'm gonna talk about in this session about the big ticket item analysis. So this is normally called the kind of analysis for preparing a embodied carbon reduction strategy. It is defined in the LETI embodied carbon primer and the design the climate emergency design guide as well. So, you know, you can download and find out more, obviously. Right, so so in this case, the first step to be carried out is obviously to analyze the full building. This could be a typical analysis of a full building, and it could be that you know, a few building elements are more carbon intensive than others. Okay, now, so this is a kind of typical distribution. Of course, if the bit it could be completely different. It depends on obviously building types and building elements types as well. Okay, now, if we obviously carried out a further analysis, and particularly if we try to understand what kind of building element is more carbon intensive, and particularly where all the low carbon measures are possible to be achieved, this could be a typical graph you can prepare. I'm talking about the bar chart here on the right-hand side. So in other words, it could be that, for example, so the piling, it is possible to reduce the embodied carbon emission by, for example, 58%. You know, the upper floor, in this case, it is possible to reduce by 46%. The external works by 27%. Okay. Now, I mean, of course, it is understood that the top 5 building elements are the most important building elements to be addressed. This because, first of all, you can achieve the highest reduction measures, okay, and also because what you have to consider is obviously the carbon distribution at full buildings. In fact, you can see that you know, envelope frame, upper floor, piling, and foundations are the highest emitter in terms of obviously building elements. Now, if you consider those 5 building elements, and then of course the potential for reduction in terms of carbon emissions of the top 5, it is understood obviously that you will achieve the highest embodied carbon reduction. Okay. Now, I mean, of course, it is a rule of thumb, this that if you address the biggest the biggest contributor, you will achieve you know, the highest reduction with the minimum effort, obviously. So in other words, if you would like to do something effective in a shorter time, perhaps this is the analysis you have to carry out from my point of view. I mean, of course, I don't want to say that the remaining building elements should be not explored. It is a good practice, obviously, to address all the building elements, in particular, all the low carbon measure possible within the building, obviously. And but bear in mind that of course if you will reduce 25% in external works, because the external works are 3% of the all life embodied carbon emission at full building, the reduction 25% will be very minimal. Okay, compare, for example, to the reduction you can achieve here in the upper floor. Right, so I think if you have any question, obviously feel free to ask, because now we are moving to the second part of the presentation, which is the case studies. Okay, so the first case study is the curtain wall. And so this is a case study which is actually part of, it is basically, you can download from the Syria website, and there will be, let's say, yeah, there will be this picture here and other detail. However, this case study was used for preparing the chapter 2 of the Targeting Zero book. So I am the co-author of this chapter. So, if you want to know more, perhaps, you can buy the book, and obviously you can read the full contents as well. So in this case, just to describe this case study, so it is so the facade case study, it is from a building in the King's Cross area. And so at the time when I was involved in the projects as a carbon lead, so our scope of work was to obviously reduce as much as possible the carbon footprint of the building, and therefore we ran a big ticket item analysis, as I showed before. And what it came out was that the facade had a pretty considerable impact, within the full carbon assessment, the full building assessment. So in this case, obviously, we tried to understand what it was possible to be done in order to decarbonize the facade. And what we came out was to basically analyze the existing, well, the first option facade, which was made by a kind of fully glazed building plus a facade louver, obviously to prevent direct sunlight penetration, and then of course to reduce discomfort as well in terms of glare. So let's say the first idea we came out with was to basically change a facade layout. And so instead of to have a nearly 100 glaze ratio for the facade, the proposal was to go for more or less 50% glaze ratio. Actually, if you consider the spandrel, obviously is higher. And just only by doing this, it was possible to achieve 22% abatement, considering obviously the first option, the first facade option. This because, of course, it was possible to remove, well, to not consider the facade louver, And then, of course, it is possible, obviously, to achieve this kind of 22% abatement. Okay. Now, because we were not happy about the result, what we decided to do was to apply an additional low carbon measure, meaning, so the initial idea was to have a full a typical aluminium glaze system. And what we introduced was instead of a full aluminium frame curtain wall system, to have a composite curtain wall, meaning so timber frame internally and aluminium frame externally. So of course, this obviously generated a lot of carbon reduction. And what it is possible to see is that by going from a full aluminium curtain wall to a composite aluminium curtain wall, it was possible to achieve 39% abatement. Okay. And then of course, if you if the carbon reduction is linked to the new facade layout and the new curtain wall frame, meaning composite instead of full aluminium, of course, a further reduction was possible to be achieved. Meaning 56% abatement compared to this baseline. I have to say that 56% abatement is an amazing results. But obviously, this was a kind of suggestion in order to be taken into consideration by the design team. And actually, what I was very happy was that the design team, particularly the architects and the facade engineer at the time, were very happy to take on board, mine or our advice from our consultancy, and they decided to go for this kind of layout. So in this case, obviously, the architects and the facade engineer redesigned the full facade, and they came out with a different option. Now, because of course the client was very keen on reducing the carbon, the client was keen on exploring the composite curtain wall as well. So in this case, what happened was that it was carried out a market investigations, and the market investigation was to contact, a lot of, well, let's say not a lot of, but a few facade supplier. And then what was done was we requested the cost of delivering both, so aluminium curtain wall and the composite curtain wall as well. The exercise obviously was carried out with a cost consultant as well. And what it came out was that the composite curtain wall, unfortunately, was more expensive than the aluminium option. So in this case, obviously, the client made, came out with their conclusion, and of course, they decided to not proceed with the composite curtain wall, because of course the price of the facade was out of their budget. Okay. However, from my point of view, what was very interesting in the exercise we carried out was that we basically established a new way to approach how to procure facade in the construction industry. And then, of course, it was an amazing lesson learned from everybody, obviously. So something to add to this case study is that so the reason why the alternative facade layout was successful was that the alternative facade is better performing in terms of thermal performance as well. Meaning, so this facade U value was higher than the previous facade layout. And therefore, obviously, it was able to achieve a lower energy consumption as well with with the alternative facade. Therefore, perhaps was successful for that reason as well. Okay, so I think we can go to the next case study, which is about paint and paint types. So this is a typical comparative paint types happen that could happen in any kind of projects, obviously. I think what it is important here is to understand how a comparative analysis of a particular product could be done. And so in this case, obviously, the brand is Dulux, and let's say all the options obviously are about one brand. However, it is good practice to carry out a multi-product as well, meaning in terms of in terms of supplier, okay? Because in this case, obviously, you can explore other supplier. It could be that other suppliers come with a better carbon figures, and it could be that another supplier could be cheaper and lower carbon as well. So, you know, it is good practice, obviously, to investigate a multiple supplier numbers, but you know, for the purpose of this session, this basically can give the message I would like to convey, obviously. So in other words, you can see that not all the paint types comes with the same embodied carbon emissions. You know, you can see that you know, all of them are obviously different. The lowest carbon emission is the Dulux Trade Super Matte in this case, obviously. So in this particular project, which was a interior design project, this was the selected low carbon option. Okay. The reason for selecting a low carbon option is obviously not only carbon, but of course there are other indicators as well. And actually they are very important as well, particularly for interior design. So one of the important indicators to be considered is obviously the volatile organic compound index as well. This because you know, these are paints which are going to be used for interior design, and therefore the level of volatile organic compounds is going to be important, particularly if you are reporting towards a green rating system, for example, BREEAM or LEED or another provider as well. What you can see here is that obviously from the difference between the lowest carbon option and the selected option is that the selected options comes with a better VOC level. It is nearly 100% VOC free, obviously, in this case. And what it is important to be understand as well is the EU limit value for the volatile compounds as well. So this could be another important indicators to be considered for your designs too. However, what obviously it is important as well to be considered in paints is the quality of paints as well. So in this case, the diamond matte was decided to be adopted because of the quality of the product as well. So talking about costs, obviously, this is another parameter to be considered because obviously cost is always good to be considered. In this case, it is clear that the selected options was not the cheapest. And so in this case, obviously, what was very important was to go for a high quality product and of course for low carbon, obviously, and for low VOC as well. It was a good compromise, let's say, environment, cost, and then of course, it was the option which was used for obviously the interior design. This one. What I want to mention in this case is that when you compare this kind of products, what it is important to understand is that the use of the paints, obviously. For example, if you assess paints, with closed eyes, obviously, it could be that you can consider this kind of paint as well. Okay. Now, this would be disqualified because it is too high in terms of carbon, but it would be perhaps the lowest carbon, of course, it is clear that this kind of paint is for wood and metal, and therefore not suitable for wall finishes. So in this case, obviously, what you had to do, obviously, is to reassess or to basically disqualify this option, or to consider other options as well, obviously. Okay. So we can go to the next case study. So the next case study is carpet. Again, so it is very important to carry out a comparative analysis of products. In this case, again, it is one brand as well, which is Interface. And as I mentioned before, it is always good to compare other companies as well, other supplier, because they could have better products. However, when normally dealing with this kind of items, it could be that the architects are more keen on a specific brand, and therefore perhaps the architect would like to consider only one brand. Okay, so this is another potential elements to be considered in your assessment. Just to talk about this case study here in particular, so the initial idea was to use this particular item, okay, and of course, because the project was to decarbonize the interior design scheme, obviously it was analyzed any potential alternative to the initial idea for the carpet. And what it was found out was that, of course, there were a multitude of lower carbon option. And, after talking to, obviously, the architects, it came out that this was the preferred product to be adopted. And actually, of course, if you compare the two inputs, obviously it is clear that the reduction was definitely bigger, particularly because normally carpets is over more or less the full NIA of a commercial area. And therefore, obviously, the reduction could be pretty considerable compared to the interior design project emissions. I have to say that in this case, there is so the adopted option was cheaper as well compared to the initial option, and therefore this was a win-win situation, obviously. Okay, so so the next slide is still about carpet, and the reason why I like to you know, compare those two products is because it could be that often you, let's say a project could take into consideration only one brand and not consider other brands, which could be obviously less carbon intensive. So in this particular case, for example, it is clear that the left-hand side is more carbon intensive than the right-hand side. And often this kind of approach could be a bit misleading as well, because so the Milliken product in this case is manufactured in the UK, whereas the interface option here is manufactured in the Netherlands. So it could be understood that perhaps a product which comes from a closest location could be less carbon intensive. This is not every time the case. In this particular example, I just wanted to demonstrate this, that although a product could come from a closest location, it could be that the product itself could be more carbon intensive than something which is produced more far away. Okay. I mean, of course, the bar chart speaks itself, and it is clear that obviously the blue bar, which expresses the product impact, is lower. However, the transportation impact, you know, the red part of the bars, of course, the interface transport is higher. However, if you zoom at both, obviously the interface, it is still the lowest carbon options. I like to introduce this kind of slide because it makes you think about all of this kind of analysis, and sometimes it is good practice to go deep into analysis in order to find the best carbon option, obviously. Okay, so the next session is about insulation, the case study for insulation. And so again, this is another case study. This was actually a retrofit building where the insulation was considered to be used in facade replacement or facade enhancement. This was part of the study I led for this particular project because the client was wondering if it was better to enhance the facade or to replace the facade. So in this case, you know, an analysis of the insulation types was carried out, and here are the results, obviously. So in this case, you can see that it is not only one brand, but it is a multi-brand study. However, because the facade had to be was under fire regulation, the facade insulation had to be Class A, so it should be fully non-combustible. Okay. Therefore, obviously, the two options here on the right-hand side were disqualified, you know, after understanding that obviously the insulation had to be non-combustible. unfortunately, for this kind of requirement, obviously, it was not possible to be used, for example, this kind of insulation types that comes with a very low embodied carbon emissions. It is fair to say as well that this particular insulation types, and particularly this one as well, they could have been amazing in terms of thermal performance because of their lambda coefficient, which is pretty low, particularly the phenolic foam as well. So in this case, obviously, it was considered only the mineral wool for the project, and as you can see here, although there are different types of the same brand, the embodied carbon can vary as well. And obviously for a brand type as well, the embodied carbon could change as well. This was due because of the lambda value as well that we consider. I mean, of course, in parallel was carried out a cost assessment as well, and obviously a decision was made. Throughout the discussion, throughout the analysis, what it was done was that we consider additional insulation types as well. And what we consider was to add to the equation, meaning add to this kind of graph, an additional insulation type. And the insulation type is the aerogel as well. Now, the client was very fascinated by the aerogel because obviously it was possible to deal with a reduced thickness of the facade. Okay, so in this case, obviously, what the client was interested in was that the NIA of the project could basically increase because of the reduced amount of the facade insulation. However, because as I mentioned, a cost analysis was carried out, it was found that the aerogel was not so cost efficient. Actually, it was much more expensive than mineral wool. And despite the fact that perhaps it could be beneficial for NIA, obviously was decided to drop as an option. But also because obviously the embodied carbon is definitely higher than all the solutions as well. So perhaps it was a wise decision, obviously. Okay, so we can move to the next slide, and this particular slide is to basically link the importance of facade U value and embodied carbon as well, meaning it is an excellent example to link operational and embodied altogether. And particularly here in the case study is about the study of the insulation layer of the wall buildup. Of course, the insulation layer within the wall buildup is the element that provides the thermal characteristics, okay? And therefore, the insulation obviously contributes to the embodied carbon, and then, of course, contributes to the wall U value as well. So in this case, what happened was that it was considered 5 different kind of insulation, and so the analysis was carried out by considering a fixed U value of the wall. So in this case, obviously, because all the insulation types comes with a different thermal performance, it is understood that the insulation thickness within the wall buildup was different, okay? And as you can see here, you can see that the phenolic foam thickness was to be 95 millimeter, whereas for the rock wool option, the thickness of the insulation was 160 millimeter. Now, what is the takeaway from this analysis? So the takeaway is that so at the end, what it was decided was to go for this particular option here, you know, the phenolic foam, because of course it was possible to minimize the wall thickness and to have let's say not the lowest embodied carbon, but let's say one of the lowest embodied carbon, obviously. I mean, of course, if rock wool was adopted, you know, we could have achieved the lowest embodied carbon ever. Okay. Now, this is another parameter to be considered in your design, because obviously, if here the target was to adopt, for example, the lowest embodied carbon option, what it could be is that the wall buildup had to be wider. Okay. Now, I mean, of course, if the wall buildups is wider, it could be that in order to install, you know, the rock wool, you know, there could be more subframe in order to support the facade cladding as well. And of course, in this case, perhaps although the rock wool insulation comes with a lower embodied carbon, it could be that the metal subframe could be, you know, more carbon intensive than the phenolic foam, because of course the gap would be bigger. Okay, so I just add all of this information to the presentation, because obviously these are the typical questions that obviously you should ask the design team, and particularly these are all the consideration that you should come out with all of your analysis as well. Okay, so we can move to the next. So this is, you know, the clay brick, normally facade clay brick case study. So in this case, so this is a project in Manchester, if I remember well, yes, and the idea here was to have a clay brick facade cladding, and therefore what it was explored was a different type of bricks. Okay, so in this case we used this as a baseline, and then we assessed you know, the Marshall's options plus the stone cycling's options as well. And these obviously are the results from this analysis that consider products plus transportation. So as you can see here, obviously the impacts is different for all the bricks types. And it is important as well to see the difference here in terms of transport emission. This because it depends on how the transport emission is carried out, meaning, so in this case, there are two options for transportations, and you can see that obviously if the transport is consider some vehicles rather than others, the impact could be completely different. Now, the client was fascinated by the stone cycling because, of course, the stone cycling, although is a bit higher in carbon compared to, you know, this and this option, the stone cycling comes with a amazing story in terms of circular economy. And therefore, in this case, the client was very keen on to explore the stone cycling options. However, the stone cycling option was more expensive than these other bricks as well, because it is a pretty particular manufacturing product. However, the credentials are they are very interesting in terms of sustainability and circular economy as well. I would suggest you to consider this kind of bricks because you know, a few clients could be very interested in adopting this kind of products as well, even if they are more expensive and if they are more and fairly more carbon impactful as well. Okay, so next slide, and this is the last one. Okay, so this is about structural timber, particularly CLT types. I have to say that this is a project which was in Sweden, and what it was studied in this particular project was the impact of adopting CLT for this building. Well, there were a few buildings, and the idea was to build these residential blocks using timber frame, and therefore CLT was part of the equation. So in this case, what happened was that we went through a multi supplier assessment in this case, and we found out that obviously not all the suppliers are low carbon. And then of course you can see that obviously you know, the option 2 is definitely more carbon intensive in terms of product, and that obviously this product from Sweden is definitely lower in carbon and obviously lower in transportation as well, because it was definitely closer than obviously a product coming from Austria. I have to say that this project was in the south of Sweden, okay? So the scenario could be totally different if it was, for example, in the north of Sweden, okay? And yeah, I mean, the takeaway here, obviously, it is to always consider a multi-supplier analysis, particularly because it is possible to see the carbon intensity difference, and probably because also you can basically tender through different supplier, and therefore you know, price could be more competitive as well. Okay, so this is the end of the session. I have a few reading here for all of you. Perhaps if you want to know more about you know, this subject. So all of these publications are publications where I was involved as a co-author, author, contributor, and etc. I think these slides will be publicly available from a website, so perhaps, you know, you can wait for the slide to be available, and then obviously you can download the presentations as well, so you will have all of your references in the slide deck. And thanks very much.
Thank you, Mirko. Thank you. Very informative. And I can say that what really learned from this is that the first solution is not the best. And sometimes what we believe is the best is not always the best. And because the design process is such a complicated things, and then the carbon are so key nowadays, we need to have a wider assessment. I think it was very interesting when you went through some example where maybe there was the material which was the best performing in terms of embodied carbon, but for other situation or for other consideration was not the best one, and you went for something that was good but not the best.
Yeah.
And that's important. And what I really think it was very important when you were discussing about the facade, that at the end the assessment impact design in terms of what we consider design stage. Really, you come across saying, you know, well, probably the design, the layout of the facade could be changed, and they've no needed louver, reducing the impact of embodied carbon. So for all the people who are approaching a design stage,
Yeah.
embodied carbon shouldn't be done as the last step, but is a design step. I think that's the most important things to highlight on the session today. That's my point. I would like to open the stage to question. So you can either type on the chat, or maybe turn on your camera and ask question to Mirko.
Okay, so there is one.
You can raise. Okay, then we have the first one. Have you worked at any carbon negative system option involving RAM and earth as one of the materials?
Yes, the answer is yes. So rammed earth is not carbon negative, by the way. So rammed earth is it should be considered as a kind of concrete which is poured in cement, meaning the binder. Okay, so what is I mean, of course, what is very useful for rammed earth is that what you can do is that you can use excavation for building walls, or for building, let's say, the finishes of external walls using rammed earth. But yeah, of course, it's not carbon negative, unfortunately. I mean, of course, you can save a lot of aggregate because, of course, you don't have to source aggregate, but it's not carbon negative, unfortunately.
Thanks, Mirko. We have another question about modular units for construction. Would you like to read yourself on the chat?
So could you share your experience in using modular units for construction? I'm really interested in understanding the sustainability of modular building. If modular units are designed specifically for a particular project, but cannot be repurposed elsewhere once removed, would they still be considered truly sustainable? Yeah, I like the question. Okay, and actually it is very well phrased because in the question is addressed the issue. Okay. So let's say modular units are a great solution for reducing carbon, and particularly for reducing waste on site. Okay. And obviously to speed up, the construction activity as well. The fact that the construction activity are speed up, it is possible to reduce the full building assessment emissions, meaning you can reduce the A5 module described before in the slides, meaning the construction inputs. Okay. However, the carbon reduction coming from construction and waste minimization, it is minimal to the impact you can save from procuring material for your modular units. It could be that a modular unit could be lower in carbon because there could be an optimization in transportation of the modular unit as well. This is a plus. However, and this is addressed in your question, from my point of view, a modular unit which is not demountable or fully demountable, it could be that at the end of life of a building could be considered as for demolition rather than to be deconstructed. And therefore, obviously, the advantage of a modular unit will be dissolved. Okay. What I normally like saying is that instead of design for assembling, what you should do is that you should design a modular unit to be able to be deconstructed as well. So in this case, obviously, there will be no losses at the end of life of building, or perhaps you could give the opportunity to deconstruct a modular unit.
Thank you, Miko. Very informative. Again, it's about assessing the processes. And then you said that maybe you need to go back to the design stage.
Yes, yes. So DFMA plus the construction is the key. Yes, definitely. Yeah, the DFMA, from my point of view, it does not resolve the issue fully.
Hi there. Yeah, I just want to say thank you for the presentation. Really, really informative. I think, yeah, this has been tackled from a different angle, whereby you always never really sort of try to compare the materials as you've done in your presentation. And I think for me, it's an eye-opener that next time on my projects, I'll have to sort of give myself some extra time to look at things carefully.
Yeah.
Thank you.
Okay, excellent.
Asif, please.
Hi, Marco.
Hi, Asif.
I think you sold yourself slightly short effectively on doing your presentation, because what you're doing is really quite complicated in terms of trying to assess where materials are making the most impact.
Yeah.
And sometimes when we do that,
Yeah.
especially on something like carpet, you may be just spending a lot of time not getting that much gain in the overall system.
Yes.
Do you want to, sort of like just going back a bit to your sort of like your top hitters?
Yeah.
How do you assess that for different size projects?
Are you talking about the big ticket item analysis?
Yeah, big ticket item analysis.
Yeah.
Sort of like, sort of like in terms of the scope of work, sort of like, I think we all do it, but I think it's quite important to describe effectively that is the first stage, and then you look at a product.
Yeah, absolutely. So, I mean, first of all, we have to say something that if you compare a full building assessment and an interior design assessment, of course, the magnitude of building elements changes. Okay. So in a full building assessment, floor finishes are very minimal. Okay. In a interior design assessment, floor finishes could be perhaps the biggest emitter. Perhaps the biggest emitter could be the ceiling. Okay. So, I mean, of course, the big ticket item analysis takes into consideration all of these proportion, and of course, you are able to quantify which are the biggest emitter. Okay. So in terms of, so what was the other part of the question? Because probably I can't remember.
I think you pretty much answered it, but I suppose it's the other thing is effectively, sort of like, especially with your installations, it's a trickiness to actually say that something is technically fit for purpose compared to something else.
Yes.
In terms of, take a bit of insulation, moisture.
Yeah, yeah.
Fire retardancy, a range of different things. So it's sometimes quite hard to compare products and say, oh, this is better, because in matter of fact, it might not work technically within the system.
I agree, Asif. I think so. Perhaps this presentation was to give a flavor of a general view. I mean, perhaps in terms of insulation, for example, we could really spend an hour discussing about it. And you are right, because all the parameters you mentioned are everything to be considered for a project, obviously. Yeah, I mean, of course, it is very difficult to illustrate a case study that is valid for any kind of projects.
I think that's probably my point in terms of you selling yourself short, because in matter of fact, you deal with lots and lots of complicated items.
Correct, yes.
And when we simplify them down, sometimes it gives a false impression that there's an easy answer to things, when in matter of fact there isn't sometimes.
Yeah, correct. I think what is important from my point of view is to carry out a lot of different kind of problematics, because you can basically, I mean, every project really comes with an issue, and the issue must be addressed, and this is normally a lesson learned for everybody, perhaps my presentation was simplified, but in reality, addressing a project or multiple projects, for sure the issue will be different. Yes, I agree.
Well, always a pleasure to, sort of like listen to your presentations, Marco.
Okay, thank you.
Thank you, Asif. There was Tassanum who asked a question, but I don't know if you would like to do it now, or maybe you want to type here on chat. Otherwise, you have another couple of questions here. I'll type on the chat.
Okay, so which one is the question? So hi, thanks.
That one is the one in, yes, that one.
Okay.
Sub-Saharan.
Do you have any experience with handling project in the context of sub-Saharan Africa? Yes, the answer is yes. I cannot tell you the project, but because let's say it is confidential, and I don't know if I can disclose now. Well, for sure it will be public, perhaps in the next year or next couple of years. Yeah, so probably what I can tell you is that so in sub-Saharan Africa, okay, but particularly, let's say sub-Saharan Africa could be the same case of other regions or countries where this particular subject is not well developed, meaning where the supply chain is not as well developed as it is at the moment in Europe, for example. I think from my point of view in Europe, in terms of addressing circular economy and embodied carbon is the best developed in globally. The US is following, Australia is following as well, and other regions. So the problem of regions where the supply chain is not well developed, or particularly where the demand in the industry is not as it is, for example, in Europe. Of course, when I say Europe, I consider UK as well, geographically Europe. Okay. Is that it could be that environmental data are not available, or they are not available to the extent that is needed for carried out this kind of assessments. So in that case, obviously, what you have to do is you have to look for generic materials or perhaps global information as well. To be honest, the way I can see is that obviously globally there is a lot of focus on climate change, and therefore more or less all the countries are now trying to address the subject, and I can see that documentation, certification, etc., are raising in other countries or regions where at the moment they are not so well developed. Okay. I can say so because I am involved in a few projects in Saudi Arabia, and I can see that this is the issue I mentioned before, meaning let's say it is not so in Saudi Arabia, for example, the situation in terms of this particular subject, meaning embodied carbon, life cycle assessment, circular economy, it is not well developed as it is at the moment in Europe. However, I can see that big steps are taken, very quickly. So I'm expecting that perhaps this kind of information will be available in any country or any region in the next years.
Thank you, Mirko. The next question is interesting.
So all
It's
of carbon assessment often
expanding to the urban and neighborhood.
Yeah, so all of carbon assessment often focus on buildings, but how can you apply this principle to wider what are the biggest challenge in reducing carbon across entire neighborhoods or cities? Okay. So I mean, when we talk about let's say all life carbon assessments, so in this presentation we addressed buildings only. Okay. And then, of course, the standard I mentioned is the EN 15978. Okay. However, in order to assess different items, meaning non-buildings, anything regarding non-buildings, normally we can consider part of the infrastructure. So there is a different standard to be used, and the standard, it is normally the PAS 2080. Okay. Now the PAS 2080 is normally for infrastructure, whereas the EN 15978 is for buildings. If for an assessment of a neighborhood and a city, okay, is combined together the building assessment and the infrastructure assessment, obviously it is possible to assess both, all together. Okay. I mean, of course, it is good practice to keep separately because of what is now the standard defining. But of course, you can report separately and you can aggregate everything. And so you can have the full picture, obviously.
Thank you, Mirko. Is there any other question?
Okay, I have to leave now. Thank you very much. It was okay. Yeah, thanks, Michelle.
Thank you, Michelle. If there's no question, I will hand to Dipti again.
I actually have questions for
Perfect.
So when we look at carbon, it's not when we look at materials, it's not only carbon that dictates why we need to choose it, right? Like you were mentioning for paints, you would look at VOCs. or for costing was important for the facade and things like that. So if there's a way in which we could measure more than 5 parameters for the same material, putting one next to the other, and then like scoring it in a way that you choose one over the other because of 5 out of 10 parameters that meet the criteria, then it's a better way of making the choice than like just looking at carbon only, if I'm not wrong.
Yeah, absolutely. I mean, the answer is yes, because I mean, if you are involved, for example, in lead projects where the material and resources credits are targeted, particularly for the maximum amount of points within the credit, the assessment which should be carried out, and particularly the reduction targets, should be considered more than global warming potential. Okay, so in this case, should consider I think 5 environmental indicators rather than only the carbon. And that reduction should be, I think you should achieve a reduction within 3 or 5. I can't remember, to be honest. Every time I have to read the manual. So in this case, yes, it is important, obviously, to consider a multiple indicators. And then, of course, what you have to consider as well, obviously, is the reduction. Because it could be that a material could be good in carbon, but not in ozone depletion. Or, you know, a material could be good in ozone depletion and eutrophication and not good in carbon. Yeah, so this could be a scenario. Another scenario, obviously, could be that it is a specific project that demands, for example, healthy requirements, particularly if it's under well assessment. In this case, I mean, what I normally suggest is to be creative and to create your, you know, bespoke assessment and to basically consider different parameters in order to address better the criteria of your project. You know, the paint was an example where, let's say, carbon cost and VOC were considered simultaneously. Yeah.
So it's always like measure multiple things and then put the balance between everything to choose the best one for going forward with construction.
Correct. Yes. Correct.
Okay. And if there are no consultants who are doing specific things, like who are measuring, say, different things, then at early stages, it would be to just refer the EPDs and get the idea from it, or like look at the like generic data available for these things and then put it together to balance it out.
Yeah, absolutely. So that's a typical, it is a typical process to be followed. Yes.
Okay.
Yeah.
Thank you so much. And
no problem.
If there are no more questions, I'm going to share my screen again just to ask for a small feedback from the participants. Do you see my screen? So if everyone could get your phones out again and scan the QR code and join the poll on Slido, it should appear on your screen. So please let us know what were your key takeaways from this session that you had with Mirko. Always investigate details before decision. It's complex. Clear boundaries, that's good. See 6 participants typing. Importance of life cycle, read around the subject. There's a lot of reading material that Miko has produced as well. So the slides will be sent out soon, so you can have a look at what publications to also look at. Cost versus carbon, big ticket items. That's some great answers and great takeaways from people.
Yeah, unfortunately, cost is always part of any kind of studies because, I mean, budget, obviously, capital cost, obviously, is a big concern in projects normally. I think all of you knows about it.
I mean, we are a business anyway.
Yeah, exactly.
Buildability, consider all parameters. These are great answers. Thank you, everyone. Thank you for engaging in this session and being a part of the Greener Together program. I'd encourage all of you to enroll for the future sessions coming up as well. And thank you. Luigi, do you have anything to say?
Yes, I would like to thank you again, first of all, Mirko, for accepting our invitation, because I think your contribution was key and add another, let's say, brick, sustainable with low carbon, to our let's say, program of low carbon construction. And I think it was very important. I would like to say thank you to all the audience to stay with us, listening and learning from Mirko. And of course, as it happened the previous session, it was quite a good question and answer where we open up to other, let's say, open up the landscape really of this conversation, which was good. Thank you again to Deep Tit organizing this with us. I would like just to share the slide, the image of the full course. As you can see, we had already Laura Baron on 27th of Feb. Today, 6th of March, we had Mirko. And then the next one is the 20th of March, Impact of Natural Materials on Buildings, Christia Diembley from Architape. So with the same link that you have, if you haven't done it yet, you can register for the next event, and hope you will see you on the 20th of March as well. I will stop sharing. A lot of thank you in the chat. That was great. Thank you, everyone.
Excellent. So thanks very much. Feel free to get in touch and feel free to connect on LinkedIn if you like.
Thank you all.
Thank you.
Thank you, Mirko. Bye-bye.
Pleasure. Bye-bye.